Have you ever seen a liquid dance and change shape under the influence of a magnet? Today, we're exploring the captivating world of ferrofluids, magnetic liquids that defy our expectations of what liquids can do. Stick around until the end to discover the science behind these mesmerizing materials and how they could revolutionize technology in ways you wouldn't believe. Ferrofluids are one of the most intriguing substances in the realm of physics and chemistry. These magnetic liquids can respond to magnetic fields in spectacular and unusual ways. Imagine a liquid that behaves almost like a solid when you bring a magnet close to it, creating intricate, flowing patterns. Sounds like science fiction? Well, it's very much science fact. The story of ferrofluids begins in the 1960s when a scientist named Steve Papell first created them for use in space exploration. The idea was to develop a fluid that could be manipulated with magnetic fields, something that could help manage fuel in zero-gravity environments. Little did Papell know that this innovative material would become a fascinating subject of study in its own right. But before we dive into the details, make sure to hit that subscribe button and ring the bell so you never miss out on our weird science explorations. So, what exactly are ferrofluids? At their core, ferrofluids are liquids that contain tiny magnetic particles suspended within them. These particles are usually made of iron oxide or other magnetic materials and are so small that they remain suspended in the fluid. The key to their behavior lies in these tiny particles, which are coated with a surfactant to prevent them from clumping together. When a magnetic field is applied to a ferrofluid, the magnetic particles align with the field lines, creating patterns and structures that you wouldn't see in ordinary liquids. This phenomenon is due to the magnetic dipole moments of the particles which interact with the external magnetic field. These interactions cause the fluid to form spikes and ridges, creating beautiful and dynamic shapes that seem to come alive under the influence of the magnet. One of the most fascinating aspects of ferrofluids is their ability to form complex dynamic patterns. When you place a magnet beneath a ferrofluid, you can see the creation of intricate spiky structures known as magnetic spikes. These spikes align with the magnetic field lines, and their shape and movement can be controlled by changing the strength and direction of the magnetic field. In addition to their striking visual effects, ferrofluids have several practical applications. For example, they are used in computer hard drives to help dissipate heat. In these devices, ferrofluids act as a liquid seal, helping to cool the hard drive's components by conducting heat away from them. This application highlights the unique properties of ferrofluids and their ability to serve functional roles in technology. Another exciting application of ferrofluids is in the development of new types of sensors and actuators. By manipulating the magnetic field, engineers can create sensors that detect changes in the environment or actuators that move mechanical components. Ferrofluids are also used in some advanced displays and optical devices, where their magnetic properties can be harnessed to create innovative visual effects. And now for the grand reveal. Recent advancements in ferrofluid research are opening up new possibilities for their use in emerging technologies. For example, scientists are exploring how ferrofluids can be used in soft robotics, where they could enable robots to change shape and adapt to different environments. Imagine a robot that can transform itself to squeeze through tight spaces or adapt its shape to pick up objects of different sizes. Thanks to ferrofluids, this might not be so far off. In addition to robotics, ferrofluids are being investigated for their potential in advanced medical technologies. For instance, researchers are studying how ferrofluids can be used for targeted drug delivery, where magnetic fields guide the ferrofluid to specific areas of the body for precise treatment. This could lead to new ways of delivering medications and treating diseases with greater accuracy and fewer side effects. The study of ferrofluids also offers insights into fundamental scientific concepts. For instance, the behavior of ferrofluids can help us understand magnetic phenomena and fluid dynamics on a deeper level. By experimenting with different magnetic fields and ferrofluid formulations, scientists can explore how magnetic forces interact with liquids and gain new knowledge about the nature of magnetism itself. But there's still so much more to discover. Ferrofluids are a prime example of how seemingly simple materials can have complex and fascinating properties. As researchers continue to investigate these magnetic liquids, we can expect to see even more innovative uses and scientific discoveries in the future. If you enjoyed this exploration of the curious chemistry of ferrofluids, give this video a thumbs up, share it with your friends, and leave a comment below with your thoughts or any questions you have about these amazing materials. And of course, don't forget to subscribe and hit that bell icon so you never miss out on our next weird science adventure. Until next time, stay curious,